Advanced memory manufacturing is constrained by a critical chemical precursor bottleneck. As 3D NAND flash architectures scale vertically, traditional silicon precursors fail to meet strict thermal budgets. Hexachlorodisilane, or HCDS, enables low-temperature atomic layer deposition of silicon nitride films below 550 degrees Celsius. This thermal window is mandatory to prevent degradation of underlying tungsten word lines. Global HCDS demand is scaling from 180 metric tons in 2018 to an estimated 790 metric tons by 2026. This represents a compound annual growth rate of 20.3%. The transition from legacy 96-layer architectures to advanced 280-plus layer designs drives a 290% increase in the per-wafer consumption index. The vertical scaling of memory channels requires an exponential multiplication of alternating oxide nitride deposition steps. Alternative precursors cannot match the deposition rate of HCDS at low temperatures. Consequently, physical memory density is now directly bound to the volume and purity of this single chemical precursor. The supply chain for high-purity HCDS is highly consolidated and geographically vulnerable. East Asian chemical manufacturers control 73% of global 6N to 7N purification capacity. Japan and South Korea combined command over 70% of this market. South Korea has expanded its share to 35% to support domestic memory fabrication. Achieving 6N purity requires continuous multi-stage fractional distillation. A single thermal fluctuation in these columns can contaminate an entire production batch, causing weeks of downstream fabrication delays. The manufacturing process is highly sensitive to power grid instability and raw material input variations. Logistical friction further compounds this supply chain vulnerability. HCDS is highly pyrophoric and corrosive, requiring Class 8 and Class 4.3 hazardous material packaging. This physical hazard restricts transoceanic transport to specialized temperature-controlled ISO tank containers. Air freight is legally prohibited as an emergency backup, making the global memory supply chain highly sensitive to localized maritime disruptions.